Good evening, everyone, or at least it's evening for me. So for these videos, I will give you guys some sort of warm-up to do, and then you will do them on a separate sheet, and we will turn them in at the end of each week like we do with a normal warm-up. But then you can keep track of what warm-up you're actually doing with your lesson, not just a general warm-up. Okay, so go ahead and pause the video and do those problems. I'm going to move on with the notes now. So day 2. We've been talking about a power to a power property for a while, and the power of a product and the power of a quotient. So we're still combining exponents, but now we're going to kind of combine those three properties together. So my first line is, you may need to combine several properties in order to simplify an expression. So I want you to simplify each expression and write them in exponential notation. So if I look at this first one, you guys can see it here. It's m to the 5th times m cubed. Okay, so that whole expression there is being to the 3rd power. So there's a couple ways to think of this. If I just look at my inside and I look at my PEMDAS, remember, please excuse my dear Aunt Sally, that's all the orders of the steps that you guys use. It tells me to deal with my parentheses first. So I'm going to deal with my m to the 5th times m. Remember, we have that invisible 1 with that m there. So that's a product property. So when I have the same base and I'm multiplying, I add my exponent, so that's going to give me m to the 6th. And that cube just comes along for the ride. Okay. And now it's a power to a power property. So I have m to the 18th. Okay. Another way to think of it, if you don't like that way, that's probably the quickest way to get your answer. So I'm going to rewrite my problem, m to the 5th times m cubed. What that really means is m to the 5th times m to the 5th times m to the 5th times m. There's invisible multiplication symbols between all those. Oh, you guys can't see that, I'm sorry. So I just wrote that 3 times. We're learning the whole camera. So then I have invisible 1s as my exponents here. Okay. So then, because all of these m's are the same bases, I can add all these exponents. So 5 plus 1 plus 5 plus 1 plus 5 plus 1, which will give me m to the 18. Okay. So there's that final problem. Sorry if I was a little shaky there. So now let's try an example with some numbers involved and a little division. Okay. So again, there's multiple ways to think of this, but what I would do first is look at inside my parentheses. I have 6 to the 4th times 6 cubed. Since I have the same base and I'm multiplying, I add my exponents. So I now have 6 to the 4 times 3, which will give me 12. And then that's still to the 4th power. And I'm going to bring my divided by 6 squared down here. I'm going to worry about this part later, though. Okay. So now I have my power to a power rule here. So I have my 12 and 4. So remember, a power to a power, I multiply my exponent. So I have 6 to the 48 divided by 6 squared. Okay, so we first used our multiplication property, then I used my power to a power property. Now I'm going to use my division property. So I'm going to rewrite this as a fraction, just because that makes my life easier. Now remember, when you have the same base and you're dividing, you subtract your exponents. So I'm going to have 6 to the 48 minus 2, which if you do that step in your head, that's fine too. So 6 to the 46. Okay. So that was a pretty big exponent, but that's okay. That's normal in these kinds of situations. If you need to pause at any time, feel free to do so to catch up on the notes, but I'll keep going. And again, here's one more example. If you want to give yourself a chance to try it first, pause it, and then watch me go through it with you. So again, I like doing the stuff inside my parentheses first. So b times b cubed. Remember, there's that invisible 1 there. So because they have the same base and I'm multiplying, I'm going to add my exponents. Okay. So it's going to give me b to the 4th. And again, that 5 power just comes along for the ride, and this divide by 2b squared. Sorry if you guys can't see, that's a division sign. Okay. Again, now I'm going to deal with my power to a power. So because I have a power to a power, I multiply my exponents. and just bring that division on down. Okay. Again, I like writing it as a fraction. That just helps me clarify what's going on. Now if you notice, there's no other number up top for this to be divided by with the 2. So the 2 is just going to come along for the ride in the denominator. Because it stays in the denominator, you can't just bring it up to the numerator. But then my bases can stay the same here. So now I can look at my b's. Since they have the same base, I can subtract my exponents since it's division here. So I get b to the 20 minus 2, which will give me b to the 18, and that denominator of 2 just comes along for the ride. Okay. If there had been a 4 or something up here, then I would have divided 4 by 2 to get a 2 on the top. But since there's nothing here, there's technically an invisible 1. I just leave that 2 on the denominator. Okay. So if you want a general rule, like we've talked about before, okay, when you raise a power to a power, you keep the base and multiply the exponents. I'm sorry, this is from previous day. So I'm going to stop this video and keep going with something else.